Okay, in this problem we're going to extend what we've done with empirical formula and then use the gas laws to also find a molar mass and figure out the molecular formula of a compound. So the first thing we have is we're given a compound 79.9% carbon, 20.1% hydrogen by mass. If 3.68 grams of this is turned to a gas and we're given a volume, temperature, and pressure, what's the molecular formula? So we can use that gas information to find the molar mass, but first we need an empirical formula, right? In order to find a molecular formula, you need an empirical formula and you need a molar mass. So let's just do that empirical formula first. So the first thing we're going to do is take our 79.9% carbon, 20.1% hydrogen, assume 100 grams, so we have 79.9 grams of carbon. We're going to convert that. 1 mole of carbon weighs 12.01 grams. Okay, and we're going to set up the hydrogen. 20.1 grams of hydrogen. 1 mole is 1.008 grams. Okay, this will come to 6.65 moles of carbon. This comes to 19.9 moles of hydrogen. Divide that by the smallest number of moles. 6.65, 6.65, and this is going to come out to be 1 carbon, and this is going to come out to be almost exactly, it's 2.999 or something, 3 hydrogen. So our empirical formula, is CH3. And now our molecular formula is going to be some multiple of that. Right? We just need to figure out whether it is CH3, C2H6, C3H9. So now it comes into play the gas laws. So we can do this a couple ways. We can solve for N and then put the grams over that, or we can use this molar mass equal to the density times the ideal gas constant times temperature over pressure, dirt over P. I'm going to just plug it in this way. So the first thing I'm going to find is the density. Okay, and the density is simply this mass. We're given 3.68 grams. And we're going to divide that by the volume, which we're given as 2.50 liters. That's going to come out to be 1.47 grams per liter. Okay, the temperature, again, 100 degrees Celsius needs to be turned into Kelvin. That will be 373 K. That's the temperature. Right, the density we'll put in the 1.47 grams per liter. R will be 0.08206 liter atmospheres per mole Kelvin, and the pressure we're given is 1.50 atmospheres. So we do 1.47 times 0.08206 times 373, 1.5. We get the solution of the molar mass being equal to pretty much around about 30 grams per mole. It's 29.99, so let's call it 30.0 grams per mole. Okay, so 30 grams per mole is our molar mass. If we look back at what we have here for the empirical formula, CH3, the empirical formula CH3 has a molar mass that's about 15, right? 12.01 on the carbon, 1 for each hydrogen. So we're around 15 grams per mole. Okay, and therefore the molecular formula should be twice that to get up to 30 grams per mole. So we're looking at ethane here, C2H6. Okay, and that's how we can use information about the gas and the ideal gas law to find the molecular formula of a compound if we know its percent composition by mass.